Hello guys, welcome to my channel. This is Uday Pandit and you're watching MEP Technical World. In this video, we'll discuss about how actually condenser of the chiller works. So in previous video, we have already discussed about evaporator section and its piping. What are the pumps that is used in the evaporator lines? Okay. Now, in this video, we'll focus on condenser side. So basically condenser is the part of the chiller. So this is the actually water cooled chiller. Here we have a major section. We have a evaporator, which we have already discussed in previous video, and now this is the condenser. So actually what is the use of the condenser? So condenser, here as you can see, let's discuss one chiller. So here we have a three chillers, actually two running and one standby. So its capacity is 225 TR is okay. So here actually if you look into this condenser, so basically condenser is used to change the heat from the refrigerant, which is high temperature. Condenser is a section which is, and in the tube, actually in the tube there is a water, and in the sealant, this is a sealant where actually refrigerant in, and where actually heat exchange. So what actually it does, it cools the high temperature refrigerant, which could be R410A. Okay, so basically we can say condenser is the medium where heat can exchange with the refrigerant. So basically it will cool the refrigerant, high temperature refrigerant, it will cool by this condenser tube water. Okay, now let's discuss about its piping, basically how this refrigerant cool. So inside the tube actually water will flow, water is flowing. So this is the outlet. So as you can see over here, so here we have a rubber bellow. Okay, then we have a pressure gauge, and here we have a thermometer. From this we can measure the living temperature of this condenser. Okay, now this water, okay, again here we have a valve. Okay, so this is the balancing valve, and then again we have a motorized valve. This valve will be operated through BMS, building management system, or CPM, chiller plant manager, and this is the gate valve, or we can say butterfly valve as well. So here water is leaving from this condenser outlet, and it going to where? So basically this water is actually heated water. Let's say the range of this water, let's say this is 34 degrees Celsius. Okay, this is 34, yeah, 33 degrees Celsius. Okay, but this is the actually heated water. Now this heated water, where it will go? So obviously we have to cool the water. Heated water we have to cool down. We have to get the temperature of this water around about 26-27 degrees Celsius. Okay, so this heated water actually will go to where? All of chillers. So from if you look into this chiller, here also outlet of this condenser, leaving of this condenser pipe is going through here. Same valves are same, everything is for here. We have a one valve to drain the line. So here we have a provision. If we want to drain the pipeline, so you can drain it through this valve. So here this pipeline is actually 200 dia pipe of size, it is 200 dia, so 6 18th, you can say 18th, and this is going to here. If you trace the pipeline, so again for third chiller as well, it will connected over here. So this is the header of outlet of this condenser, and it will goes to if you trace the pipe, so let's trace the pipe. It is going over, so where it is going, okay, here. So this is the section of the CT, means cooling tower. So this is the actually cooling tower, which actually cool this condenser water, outlet water, condenser water, outlet water. Basically this is the condenser outlet water is basically heated from like 34-36 degrees Celsius, then it goes to this inlet header of the, this is basically inlet header, which dia is 300 mm. So this is the inlet header of cooling tower. So here we have a cooling tower sections which actually cool this condenser outlet water. Okay, so here we have a header. So this is the, so here it collects all the outlets of the condenser, chiller condenser water, and from here, so actually if you talk about cooling tower, so this is also a heat exchanging medium through the ambient. So this is actually open loop system. If you talk about in the chiller, so evaporator side is closed loop section, but it is open loop section. So here might be chances of the biological growth, contaminated contaminated growth. So here we are maintaining the water quality with the help of the dosing system. So nowadays that 3D Tetra Nalcomate is also available. So it is auto dosing system. According to the water quality, it will dose accordingly to maintain the pH and chlorine of the cooling tower. Okay, so here, so this is the two number of, we can say twin cell cooling tower. So in one cooling tower basically there is two section. Okay, so now if you count it, there will be 4 cell but 2 cooling tower. So 2 cell in each cooling tower. So capacity, if you talk about its capacity, it is 300 TR, ton of refrigerant. So 3 cell out of 4 cells shall be used for chiller. So there are 4 cells, so we can use 3 cell as a normal operation and 1 will be standby. So we talk about its structure. So here we have a, this is the CT fan, cooling tower fan, which actually extract the heat from this water. Okay, and this is the body of the cooling tower. Okay, and this is the nozzle where actually hot waters from here. If you look into this, this is the 150 dia inlet pipes, and it goes over here, and here we have a motorized valve. Okay, so this is the motorized valve, and this is the balancing valve to balance the GPM according to this city capacity. Okay, so here actually this condenser outlet hot water is entering towards this cooling tower at the top of the cooling tower where we have a nozzles. From here actually it will spray through the fins. So this heated water is split into several forms, and it will fall to this collection tank. So basically this is the collection tank, catchment area we can say, and this is the surrounding cover we can say, where this is the safety reason, and this is the fan which actually extract the heat towards the ambient. Okay, hot water entering from the top, it will spray like this, and it will goes to the fins, and it will split the waters and spray towards the down. So during this process, water will get cool, and it will actually fall into the catchment area, and from the catchment area, basically this is the foundation where this cooling tower is installed, and from the fountain, suppose here is water collected of similarly for here. So in one CT fan, as I have already told, two cells, so for two cells, actually two inlets over here, so one cell for this side and one for this side, and similarly for other CT cooling tower as well. So header is common, so this is inlet and this is inlet. So all hot water is suppose entering here, suppose 34 degrees Celsius, let's say 34 degrees Celsius, 34 degrees Celsius. Now if we'll spray through from the tops and getting down, and it's so then water temperature actually it becomes here, let's say 30 degrees Celsius. Okay, so 30 degrees Celsius. Now this collected water, which temperature is basically low as compared to this, because here this cooling tower cools the water, and from here as you can see, so this is the actually here as you can see, this is the outlet of this cooling tower. Okay, so this is the outlet of cooling tower of each cell. So this is the cell, here we have one valve, here we have another valve. Okay, so water is entering through this four pipe from this header, and then water is leaving from this cooling tower, from the base of this cooling tower collection tank. So from here water is get cooled, and it is again similarly from here water is again going to, this is the actually cooled water we can say as compared to this one. So again this water will goes to, then this water will travel and it will enter to the where. So here we have a pot strainer. So this strainer will strain the any contaminated, physical contaminated debris, if it, because it is open, that's why here we have a pot strainer, and both of side we have a isolator valve, and one is bypass line. Okay, so one is bypass line. So with the help of this actually it will enter to this pump. So here we have a three pumps. So these pumps are called condenser pump. So two are working and one is standby. So three nodes of condenser pump, two working and one standby. If we talk about its capacity, this is the 675 US GPM, gallon per minute is. So here if we talk about its pump arrangement, so here we have a header. So this is the suction header of the pumps, which actually suck the cooled water as compared to inlet of the cooling tower. So it will suck the water from this header. So this is the from the cooling tower. So this is the valve, and this is a strainer, pump strainer, and this is pressure gauge, this rubber bellow, and from the discharge side as well, here we have a bellow, then pressure gauge, then this is the NRV, non-return valve, and this is the valve, isolation valve at discharge side. Okay, now again goes to this discharge header, so all of three. Okay, three pumps. Now from the discharge, so this pump will actually suck the water which is cool form, let's say 30 degrees Celsius, and then it will travel and it will flow towards the where condenser inlet. Okay, so this is the condenser inlet. So here again each of three of chiller, so was like this. Okay, so when it enters, so over here again we have an arrangement. So this is the valve inlet side, and this is the temperature thermometer where you can measure the inlet temperature of this condenser cooling tower, actually outlet water, and it goes to the inlet of this condenser. So basically this water actually enter into the condenser tube, and where actually heated form of refrigerant in the cell which actually exchange the heat. If suppose this water temperature is 30 degrees Celsius, if it will increase like it will transfer, it will gain the heat from this refrigerant, heated from refrigerant, it exchanges the heat from the heated form of refrigerant in the cell, then again at outlet form its temperature will rise around about, let's say 33 degrees Celsius, and it goes to again this heated water towards the where cooling tower to get the cool. So this process again repeat. Okay, repeat again and again. Let's say its outlet temperature becomes 27 degrees Celsius of this condenser, then CT pan will be automatically off. Okay, but circulation pump, we have to run the circulation pump. So this condenser circulation pump. Okay, so over here, so in this process actually condenser part works. Even due to bad quality of the condenser city waters, this cycle water, actually it will affect the efficiency of the chiller. So it will consume more power, even it will not be effective. That's why we have to maintain the cooling tower water, so this circuit line water quality, because we have to maintain the condenser approach temperature at least 2, below than 2 would be enough, not more than 4 degrees Celsius. Okay, so this is the only, with the help of the we can maintain the water of this cooling tower. So here we can install the dosing system, auto dosing system, that can we prevent from this any contaminated. Now let's discuss some more accessories on this cooling tower. Say here we have a makeup water, so due to evaporation loss, okay, during the circulation it gets lost due to evaporation, so water level get decreased. That's why we can fill the water through this valve. So there are two options. One can be soft water, which can be used as a STP treated water, and another is direct from, even if we have a hotels like treated water, even we can fill. So there are two options over here. One is quick fill and another from overhead tanks, that can be soft water makeup tank, cooling tower makeup tank. Okay, and another is yeah another is yeah this one. So this one is actually drain pipe. If we want to clean the cooling tower, then we have to first drain the water, means first isolate the valves, then we can open this drain line and it will drain. Okay, so to drain this line, and even overflow pipe is also connected to this drain line. Okay, so for this two city fan cooling towers, so these are the two overflow and drain line. And another is, this is basically equalization tank, equalizer line. Okay, so with the help of this, it will maintain the equal level of the all waters in all cell. Okay, so hope you guys understand about basically condenser cycle over here in the chiller, water cooled chiller. So thank you very much. Please like, share, comments and subscribe, and also hit the bell icon so you'll get notification regarding my upcoming videos. Thank you very much. See you again in next video.